Hi everybody, Mr. Byrne here. Miss all you guys. Uh, I put together this video to try to help you understand last Thursday and Friday's assignment regarding the atoms and the ions. Because I've realised going through these discovery education assignments, they talk a lot about cations and anions and ions in general, and I don't think we've covered that deeply enough. So that's why I gave you that assignment. Uh, I know some people struggled with it, so I've done my own little video to help explain what it is. I hope it works. Any questions, please email me and stay strong.
Okay, so here we have the periodic table of elements. It's a little bit small, but it's the only one I could fit on my phone screen. As we all know, this is a list of all the known elements of the universe, starting at the lightest, number 1, hydrogen, and going all the way up to 118. I'm not even going to try and pronounce that. The elements are listed in columns or groups. Both mean the same thing. And they go up and down. And they're also organized by periods or rows. Both mean the same thing, and they go across. So for example, hydrogen is in group 1, and it's also in period 1. Right there. So there's 18 groups going from 1 to 18, and there's 7 periods or rows. 1, 2, 3, 4, 5, 6, 7. Now, we want to focus our attention on ions. And at this stage, I think we all know that an ion is an electrically charged atom. It can be either negatively charged or positively charged. So let's have a look and see how this table is going to help us predict what each atom will, what type of ion each atom will form. So to make things easier, I'm going to block out from 19 up to 118. Simple thing to do. There we go. They're gone. Because we're only going to focus our attention on the first 18. There's no need to go any further than the first 18. And we're going to relist the groups. 1, get rid of the A. 2, we're going to skip the transition metals, and we're going to go straight to group 3, 4, 5, 6, 7, 8. So now we've got 8 groups instead of 18. But this is going to help us. It'll make things a lot simpler. Now, in group 1, hydrogen, lithium, and sodium, if you notice, they're all uneven numbers, a 1, a 3, and 11. And in group 2, they're even, 4 and 12. And then uneven, even, uneven, even, uneven, even. This pattern will become obvious as we go on. Remember that all atoms would like to have a full outer shell. If they only have one shell, the first shell, the most they can have is 2 electrons. If they need another shell, the second shell, the most they can have, and that is 8. Now I'm going to change things a little bit here. For these particular 18 elements, if they have 8 in their third shell, that's also full. If you go past these 18, things change. But for our focus, full first shell is 2, full second shell is 8, and full third shell is 8. And atoms, for some reason, always want to have a full outer shell. Let's look at hydrogen. Hydrogen, atomic number 1. So it has 1 proton and 1 electron circling around. There's the proton in the nucleus, and here's the 1 electron flying around like this. It would like to have 2. So what it usually does is it meets another hydrogen and they share an electron. They don't even give them up, they share electrons. Let's go down a step further. Lithium, Li, atomic number 3. In the nucleus it has 3 positive protons. Remember the first shell, you can only have 2. So it's got 1 left that has 3 altogether, so it's got to put that in the second shell. And there's that 1 lone electron. It would like to have just 2. So it has a tendency to get rid of this electron. It has 3 protons, 3 pluses, 3 electrons, 3 negatives. It's completely neutral. However, if it gives away this electron, it will now just have 2 electrons. 2 negatives and 3 positives gives us an overall positive 1. So it has a positive 1 charge. And it will be written like Li, the symbol, and a small positive up there. All the elements of group 1 have a tendency to give away 1 electron because they all have 1 electron in their outer shell. Group 2, right here, as you might guessed, has 2 electrons in its outer shell. Beryllium, atomic number 2, 2 protons in the middle. That's the nucleus. I'll just shade in a little bit. And then the first shell, like everybody else, has 2 electrons. The next shell, or the outer shell, also has 2 electrons. We would like to get rid of these 2. So it's left with a full first shell with 2 electrons. So it has, oops, that's 4 protons. Fuck. They're also listed in periods or rows, and the periods and rows are arranged horizontally from left to right. So period 1 contains 2 elements, hydrogen, helium. Period 2, 1, 2, 3, 4, 5, 6, 7, 8 elements, and period 3, period 4, all the way down. Just remember columns and rows, or columns or groups go up and down. Periods and rows go across. So what we're trying to understand is how can we use the periodic table to determine what ion an atom will form? Well, if you can remember from a week or 2 ago where we talked about how electrons fill up an atom. The first energy level of an atom can hold 2 electrons. The second energy level can hold 8. And for our purpose in this particular assignment, we can say that the third level or third shell can also only hold 8. As we're only going to be dealing with the first 18 electrons, this octet rule will hold true. So I'll repeat again, the first level can hold 2 electrons maximum, the second level can hold 8, and the third level can hold 8. So let's look at the groups. Group 1, it's got hydrogen, lithium, and sodium. Hydrogen's atomic number is 1, lithium's atomic number is 3, and sodium's atomic number is 11. Now if I put those electrons into their orbitals, hydrogen only has 1, so there's the nucleus and there's that 1 electron. It would like to have 2. Here's lithium, atomic number 3. There's the nucleus where the protons are. Here's the first energy level or shell. We put 2 electrons. It's got 1 left because there's 3 in a total. So there's the next energy level, and there's that 1 electron. I think you're starting to see a pattern here. If you look at sodium, atomic number 11, there's the nucleus. First energy level, as you know, has 2. The second can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. The next one can also hold 8, but we only have 1 left. We've used up 2 and 8 is 10. We have 11 altogether, so we put the 1 there. Now the reason all of these elements are in group 1, hydrogen, lithium, sodium, hydrogen, lithium, and sodium, is, as you've guessed, they all have one electron in their outer shell. And they would very much like to get rid of that one electron. Because if they did, hydrogen's an exception. Of course, there's always exceptions. But if lithium gave away that one electron, it would have a full outer shell of 2 electrons. If sodium gave away that one electron, it would have a full second level of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And something similar applies to the second group, group 2. Let's just look at beryllium and magnesium. Beryllium, magnesium. Beryllium atomic number 4, magnesium atomic number 12. If I draw the beryllium atom, it's the nucleus, 2 in the first, it's full, and then I can put 2 in the second. If I come down to magnesium, there's the nucleus, I'll put 2 electrons in the first, then the second one can hold 8. 1, 2, 3, 4, 5, 6, 7, 8. We got 2 left. 2 and 8 is 10, but we have 12. So the third shell, as you've guessed, also holds 2. So you notice that boron in group 2 has 2 electrons in its outer shell, and magnesium in group 2 has 2 electrons in its outer shell. And this works all the way across the board. Remember, we're not doing these transition metals. We're just doing group 1, group 2, group 3, group 4, 5, 6, 7, and 8. So if I go from group 1 all the way across to group 8, you'll know how many electrons are in the outer level. Looking at group 7, we can see fluorine and chlorine. Group 7, fluorine and chlorine. So let's just write down group 7. And how do they have 7 electrons in their outer level? Well, fluorine has atomic number of 9, so that means it's got the nucleus, 2 in the first, and you've guessed it, 7 in the next one. Now if we go down to chlorine, atomic number 17, there's the nucleus, 2 in the first, then 8 to fill it up. Fill up the second shell. That's 10 altogether. And the last shell, you guessed it, 7. So using that information, let's have a look at chlorine. We just did it, so it should be still fresh in your mind. The atom is chlorine, atomic drawing. In this situation, we just put a dark spot for the nucleus because we're only concerned with the electrons. First shell 2. Remember, it goes 2, 8, and 8. Second shell has got 8. And then the last shell has 7. 2, 3, 4, 5, 6, 7. Because we know chlorine has an atomic number of 17. So 2 and 8 is 10, and 7 is left. Let's write all that in. Protons, atomic number 17, so therefore has 17 protons. Neutrons, we're not worried about. Electrons, if it has 17 protons, it must have 17 electrons. The number of valence electrons, that's the electrons in the outer shell. We just said 1, 2, 3, 4, 5, 6, 7. Now it's got 7, it would clearly love to have 8. So what do you think it will do? Will it gain an electron or will it lose 7 electrons? Well, it's much easier to gain 1, so it's going to gain 1 and form an ion. Let's have a look at the ion symbol in charge. Well, the ion is the chemical symbol, which is Cl, uppercase C, lowercase l, and the charge. Well, if it gains an electron, remember electrons are negatively charged. If it gains 1 electron, it will have a charge of -1. The ion drawing is similar to that. Nucleus, first level 2, second level 8. And the third level. We used to have 7, but remember we just gave it an electron. So now it has 1, 2, 3, 4, 5, 6, 7, 8. And that's why it has a negative charge of 1. It got this extra electron from somewhere. So let's put them in. Protons, it had 17. Neutrons, we're not worried about. Electrons, it now has 18. 2 and 8 is 10, and 8 is 18. Were electrons lost or gained? They were gained. How many? 1. So that means it's negatively charged because it got a negative electron. So anions are negatively charged. So I hope that helps clear up any confusion with this assignment.